Hi, my name is Christian and I will show you the FMU Input Smoother feature of Dymola. So, what's behind this? Dymola co-simulation FMUs using DASL or CVOD often exhibit slower performance when inputs are updated frequently. Multi-step solvers like DASL and CVOD assume that the function f is continuous and smooth and may internally integrate beyond the do-step interval. Therefore, when inputs U change at a communication point, the solver must be reset. The question is this reset behavior always necessary? Let's assume we have a continuous input signal, which we want to provide to the FMU. At the discrete communication points, we can provide this value to the FMU, and a common FMU implementation would be a zero-order hold. I call it the classical FMU. The FMU internally uses the provided input value over the whole do-step interval, and when the new value is provided at the communication point, the solver is reset and the simulation continues with a new input value. Now the rationale is to delay the input to implement a first-order hold. So instead of the dark red discontinuous input trajectory, we use the orange line, continuous input trajectory. So the input smoothing is designed for multi-step solvers such as CVOD, DASL, or IDA. The great benefit is that the reset of the solver at the communication point is avoided, and the number of events is reduced, and in many cases, the simulation speed improved. Optionally, there's also a predictor compensation implemented, which adapts the solver's history representation to the new input derivatives. So now let's have a look at an example. I used the transport refrigeration cycle from the TIL examples. I added two inputs for the compressor speed of the high pressure compressor and the low pressure compressor. Then I export the model as co-simulation FMU to 0, and after translation, I will go to the Tools, Options, Variables to set the input smoother flag. And then I will export a second FMU with the same setting, but I will change the name. I will append an IS. So let's get to the FMUs. I will import the FMU to our Excel simulator. I will provide an input trajectory. After 100 seconds of simulation, I will update the inputs every 100 milliseconds. And I will have a look at the CPU time and the event counters. So now I simulate the model, and I can see that the simulation takes about 3.7 seconds, and that more than 100 events were triggered. If I do the same thing for the input smoothed FMU, provide the input trajectory and run the simulation, I can see that the simulation is much faster and that the event counter is not increased. So thank you for listening. Hope this new feature will help you.